Ever wondered how Netflix suggests movies or how Spotify recommends songs? One of the techniques they might use is a fascinating algorithm known as the K-nearest neighbors, or KNN for short. KNN is a non-parametric and instance-based learning algorithm, which essentially means it doesn't make any assumptions about the underlying data distribution. Instead, it makes predictions based on the similarity of data points. Now, how does it work? The process is quite simple. During training, KNN stores the entire training dataset in memory. Then, when a new data point needs to be classified, KNN searches for the K nearest data points in the training set. This search is based on a similarity metric, usually the Euclidean distance, between data points. Once the K nearest neighbors are identified, the algorithm performs a majority vote among them to decide the class of the new data point. But so what is this K we're talking about? K is a hyperparameter that represents the number of nearest neighbors to consider. The choice of K is crucial and can greatly impact the algorithm's performance. A smaller K makes the model more sensitive to noise in the data and can lead to overfitting, while a larger K can smooth out the decision boundaries but might miss finer patterns in the data. Choosing the right K isn't always straightforward. It depends on the specific dataset and problem. Common methods for choosing K include cross-validation and grid search to find the optimal value that balances bias and variance. While Euclidean distance is the most commonly used distance metric, you can also use other metrics like Manhattan distance or Minkowski distance, depending on the characteristics of your data. KNN is simple to understand and implement, and can be used for both classification and regression tasks. However, it's not without its drawbacks. It's computationally expensive for large datasets because it requires calculating distances to all training points. It's also sensitive to irrelevant features and noisy data, and choosing the right K can be challenging. Furthermore, pre-processing your data is crucial before using KNN. Feature scaling is important as KNN is sensitive to the scale of features. Also, handling missing data is crucial to prevent any bias or inaccuracies in predictions. KNN finds its applications in various domains. It's used in recommendation systems, image recognition, fraud detection, and more. However, KNN does have certain limitations. It doesn't learn explicit patterns from data. It memorizes the training data. It can perform poorly when the feature space is high-dimensional. Also, the algorithm's performance can be affected by the choice of distance metric. In a nutshell, KNN is a simple, yet versatile, algorithm for classification tasks. It's suitable for small to medium-sized datasets and situations where you don't have prior knowledge about the data distribution. Properly choosing K and handling data preprocessing are essential for achieving good results with KNN. So next time Netflix suggests a movie you might like, remember KNN might have played a role in it.